This video is for graphing polynomial functions. So looking at example 1, it says graph the function f of x equals x cubed plus 3x squared minus 6x minus 8. So for step 1, we need to find our zeros. Okay, as we learned with the in behavior, depending on what the degree of the polynomial is, that's how many zeros we should have. So this is a cubic function, a degree of 3, meaning we should have 3 zeros. So when we're looking for zeros, we look to see if we can factor it. I can't factor this by grouping. It's not a sum or difference of two cubes. So therefore, I must guess until I get a remainder of 0 when using synthetic division. So I'm literally just guessing. So x equals 1. That's my first guess. I always start at 1. So that goes in my little half box. And then I bring down my coefficients. So I have 1, 3, negative 6, negative 8. I also have to make sure I'm not missing anything. So I bring down the first term. And I multiply. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. And then I add again. Negative 6 plus 4 is a negative 2. 1 times negative 2 is a negative 2. And negative 8 plus negative 2 is a negative 10. So in this case, my remainder is not 0. Therefore, I must try again until I get a remainder of 0. Okay? So what this does tell me is I have a point when x equals 1. I have a point at negative 10. So 1, negative 10 is a point, but it did not give me my 0. So now what I'm going to do is I'm going to guess a new number. So I'm going to try negative 1. So negative 1 is now going to go in my half box. I have 1, 3, negative 6, and negative 8. I repeat the process. So I bring down my first term, 1. Negative 1 times 1 is a negative 1 plus 3. I get 2. Negative 1 times 2 is a negative 2. I add them. I get negative 8. Negative 1 times negative 8 is a positive 8. And I add them and I get 0. So yay, I get a remainder of 0, meaning this is a 0. Okay? Now I need two other zeros. So remember, this is my remainder, my constant, my x squared. I have let's see, x squared plus 2x minus 8 left over. So what I need to do here is I need to factor this. Now this is a part where I can actually factor. Okay, I can factor this. So I'm going to use the x and the box. I told y'all that would never go away. Okay, the x and the box. So first times the last, I get a negative 8x squared. 2x on the bottom. What can I multiply to get a negative 8? Add to get a positive 2. That would be a positive 4x. Negative 2x. I go to the box, x squared minus 8. And then I do my 4x, my negative 2x. From here, x squared and 4x have an x in common. X times x gives me x squared. X times 4 gives me a 4x. And x times negative 2 gives me a negative 2x. So the factor comes out to be x plus 4 and x minus 2. Now, in order to solve it, I need to set each factor equal to 0 to solve for x. So this becomes, I subtract 4, it becomes x equals negative 4. I add 2 on both sides here, so x becomes 2. So I have a 0 at negative 1, I have a 0 at negative 4, and I have a 0 at positive 2. So I'm going to go ahead and plot those. So positive 2, negative 1, negative 4. Those are my zeros. Okay. I also need to find my y-intercept. So my y-intercept. Remember, it's just the constant. If there's not a constant, then it's 0. So if I look, my constant in this is negative 8. So my y-intercept is 0, negative 8. So 0, negative 8. I plot that down there. I did get the point 1, negative 10. So I have that as well. Now, I need to look at my end behavior for the graph. So if I'm looking at it, it's odd, meaning it goes in different directions. Again, cubed is odd. And my leading coefficient is a positive 1, meaning my right side must go up. Okay, so it has to go up from here. That means this left side has to go down. And then I just connect the points from there. So it goes here, here, and then I stop and I don't have any points. So I need to find a point at -2 and -3. So to do that, I'm literally just going to plug in the points using synthetic substitution. So I need to do -2. So I have 1, 3, -6, -8, and I go back to my original equation for this. So I repeat the process. I bring down my 1. Let's see. -2 times 1 is -2. 3 plus -2 is 1. -2 times 1 is a -2. Oops. Is a -2. -6 plus -2 is a -8. -2 times a -8 is a +16. -8 plus 16 is a +8. So I have a point at -2, +8. So I'm going to plot that. -2, +8. 1, 2, 3, 4, 5, 6, 7, 8. So I have a point here. I'm going to repeat the process, but now I'm going to use -3. So I have 1, 3, -6, -8. So I bring down my first term. -3 times 1 is a -3. 3 minus or 3 plus a -3 is 0. -3 times 0 is 0. -6 plus 0 is a -6. -3 times -6 is a +18. And then I add those and I get a +10. So now I have a point at -3, +10. So I'm going to plot that. And that should be right there. So then I can continue. It connects here and then it goes back down. This is a rough sketch. It does not have all of the points. We just had the whole number points that works for us. Okay, so let's try this again with a new function. And I just have 2 examples in this video. So now we want to graph the function -x cubed plus 3x squared plus x minus 3. So again, we need to start by finding our zeros. When we do this, it's literally just a guess. Let's use purple. So I'm going to guess using x equal 1. I always start with x equals 1. So here we go. My coefficients, -1, 3, 1, -3. Awesome. So I bring down my first term, -1. 1 times -1 is a -1. Let's see, 3 plus -1 is 2. 1 times 2 is 2. 1 plus 2 is 3. 1 times 3 is 3. -3 plus 3 is 0. Yes, first try. Lucky us. So this is a 0. So now I need to find 2 more zeros, again, because I have a cubic function. So I am left with a remainder of 0, a constant, an x, and an x squared. So I have a -x squared plus 2x plus 3. Before I even start this, I noticed my x squared is negative. I don't really like that. So I'm going to divide out a -1, which is like a factor. So it changes all my signs, and it's going to make it a little easier for us. So I like that a lot better. From here, I can do the x in the box. So I get a -3x squared minus 2x. That gives me a -3x and a positive x. So I have x squared, x, -3x, and a -3. So this has x in common. X times x is x squared. X times -3 is -3. X times what is x would be a +1. So I get x minus 3. I get x plus 1. I still have that negative out in front. I don't have to worry about this negative because it doesn't have a variable with it. Now, if it was an x, then I would have to worry about it. But since it's not an x, I don't have to worry about it. So I get x minus 3 equals 0. I get x plus 1 equals 0. I add 3 to both sides here. I get x equals 3 as a 0, and I subtract 1. And I get x equals a -1. So my 3 zeros are 1, -1, and 3. So I'm going to plot those. -1, positive 1, and 3. From here, let's see, I need to find my y-intercept. So my y-intercept, again, it's my constant, so it would be 0, negative 3. So I'm going to plot that 1, 2, 3 right here. I'm going to look at my end behavior now. It's odd, so different directions, but now my leading coefficient is negative, meaning my right side must go down. My left side has to go up. So I start kind of connecting points to see. Notice now I'm missing a point at 2, so I'm going to plug into to see what that value is. So I have 2, so negative 1, 3, 1, negative 3. I bring down my first term, which is a negative 1. 2 times negative 1 is a negative 2. 3 plus a negative 2 is 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. Negative 3 plus 6 is 3. So I get a point at 2, 3. So I'm going to plot that 2, 3 right there. And then I continue my line and it looks like that. So this is the function for f of x equals negative x cubed plus 3x squared plus x minus 3. And this is how we graph polynomial functions. Again, it's not very accurate. It's kind of more of a sketch, but it gets us to know our zeros, our y-intercepts, and our end behavior.